This is lesson 3.5, page 136, graphing linear equations in slope-intercept form. In this lesson, you will learn how to find the slope of a line, how to use slope-intercept form of a linear equation, and how to use slopes and y-intercepts to solve real-life problems. There are definitely going to be some no calculator skills taught in this lesson. So when I assess you, the assessment would be no calculator for at least parts of this lesson, if not the entire lesson. So definitely prepare yourself to be able to do some of these things without a calculator. Let's talk about what slope is. The slope of a line passing through 2 points is the ratio of rise, the change in y, to the run, change in x. I always teach ratio. Slope is the ratio of rise to run. If you can remember rise over run, you can remember slope. Now the rise is the change in y, and the run is the change in x. Now there is a little formula for that right here. Slope always equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll talk about that more in a little bit. When the line rises from left to right, the slope is positive. This would be a picture of a positive slope. When a line falls from left to right, the slope is negative. That would be a picture of what's going on down here, a negative slope. Now, the book doesn't say this, but I'm going to. You can calculate slope from a table by using this formula. Let me write the formula one more time, and I wrote it here. Or you can count slope if given a graph. So what I'm saying here, if you have a graph like these are, you can get the slope without even using the formula by just counting squares. Okay, so let's see that at work on these two examples. They want us to find the slope of the line. Okay, so you should be able to count squares. Slope is rise over run. So look at this. We have a point here and a point here. So count with me. To get from this point to this point, I would go up 1, 2, 3, 4. I'm rising 4. And then I'm running 1, 2, 3, 4, 5, 6. I'm running 6. And you should always put that in lowest terms. 2/3. That's the slope for that. I don't even need a formula. Now the book use the formula, but you don't even need to. You can count squares. This is something that even if you think you're not great at arithmetic, you should be able to do this. Okay? Let's go to this one. The slope is rise over run. Now rise could mean up or down. Like in this problem, you notice how I go from left to right. Here's 2 points. Start on the left point. I got to go down 1, 2, 3. So my rise was -3. Negative means we actually dropped. And then here's the run. 1, 2. -3 over 2 is the slope of that problem. So if there's a picture, if you have a picture, you can just count squares to get your slope. Now, if you don't have a picture, you're going to have to make a calculation, which we're going to talk about next. All right? And I wrote that here. If you have a graph, you can easily count squares. The work isn't required. Okay? What I would like you to do is quickly pause the video, and I want you to try these 3. You should be able to just count squares and get those. Okay, I'm back. So this first question, I had to go down 2 and right 5. Down 2, right 5. So that would be a slope of -2/5. Now, for the next one, I had to go up 4 and over 6. 4 over 6 is 2/3. This last one, we got to be careful. The book got sneaky. I hope you noticed it. Look at the scale. You notice how the scale is not 1? So when you go up 1 square, that doesn't count as 1. That counts right now as 2. So you can count with me. I'm going up 2, 4, 6, and then half a square is 1 more, 7. I went up 7, and then over 2 and 1/2 makes 3. 7/3 is my slope. Another way of looking at this, look at this carefully. You notice 3? Isn't 5 and 2 3 away from each other? And you notice 7? Isn't 4 7 away from -3? So that's kind of what the formula does for you. Let's talk about the formula, because if you don't have a picture, you're going to have to use the formula. So let's find slope from a table. The points represented by each table lie in a line. How can you find the slope of the line from the table? The answer to that is by using the formula. So we're going to use the formula. We will use m equals this formula. Now, I'm going to go through what that formula is telling you in a minute. What is the slope of each line? Now, what does this formula mean? Okay? What do these little subscripts mean? It means, I'm going to highlight this, there's 2 points you got to pick. 1 point, what they call y sub 1 and x sub 1, that means one of the points. And then there's another point. This is saying I need you to pick 2 points. Okay, so let's look at what the book did for A. I don't care what 2 points you can pick any 2 points. So it looks like the book, for the first point, picked the point 420, and the second point they picked was 714. Okay, so you see how they have 714, color coding, and 24, 420. Okay, so let's do that. Here is x sub 1, y sub 1, and this point was x sub 2, y sub 2. So do you notice? They took 14, they put it in for y sub 2. They took 20, which is y sub 1, put it there. 14 minus 20 is -6. And then for the x values, x sub 2 was 7, and x sub 1 was 4. 7 minus 4 is 3, and -6 over 3 is -2. The formula works. Okay? Let me go back to this sample problem. I just want to do the sample problem using the formula just so you see you get the same answer. So let's say that I call this point 1, and I'll call the second point, this is going to be my point 2 in green. So here's what I do. I take the second y value, which was 1. Let me write the formula down first. Okay? I'm going to take the second y value, which was a 1, minus the first y value, which was a 3. And then on top of that, I have, on the bottom, I should say, the second x value was a 1, and I'm subtracting off the second x value, which is a -4. The first x value, I meant to say, -4. Okay, let's do this. 1 minus 3 is -2, and 1 minus -4, add the opposite, that's +5. Do you notice I'm getting the same answer? So this formula will always work if you need to use it. Very convenient to use to find the slope of any points. So the second table, let's go ahead and I tell you what, I'll use this point and I'll use that point. I'll call this one point 2 and this one point 1. So I take the y value of point 2, which is 2, minus the y value of point 1, which is 2, and I put that over the x value of point 2, which is 1, minus the x value of point 1, which was -1. 2 minus 2 is 0. 1 minus -1 is 2, and 0 over 2 is 0, and that's what they're getting here. This line would have a 0 slope. That means it's a flat horizontal line. It's a horizontal line, okay? And I think they mentioned that here. There's no, no, I guess they just put the slope as 0. That means it's a horizontal flat line across my paper. Let's do this one. I'll call this point 2, and I'll call this point 1. Okay, so ready? Take your slope. You take the y value for point 2 minus the y value for point 1 over the x value for point 2 minus the x value for point 1. 0 minus negative 3 is positive 3, and negative 3 minus negative 3. Add the opposite. That's 0. You can't divide by 0. That's undefined. Okay, that means the line is completely vertical. It's a straight up and down line. It's a completely vertical line. What I'd like you to do is pause the video and try these two. Try and get the slope of those two. Pick 2 points, find the slope of those two tables. Okay, I'm back. Let me color code this. Okay, so for this first question, I called that point 2 and I called this point 1. So, ready? Can you see the point 2 minus the point 1? I have the y values on top, 15 minus 10, and the x values on the bottom, 4 minus 2. That's 5 over 2. 5 halves is the slope. That's a rise of 5 versus a run of 2. On the second question, I called this point, point 2, and this point, point 1, and I take point 2, which you can see, 5, negative 9, there's my 5 and negative 9, and I subtract away my y and x of point 1. See how those match up. I get 3 over 0, that's undefined. Undefined is a straight up and down line, which we should quickly, this you should get in your notes next, right here, this concept summary. Okay? A positive slope is a line that rises. A negative slope is a line that falls from left to right. A slope of 0 is a flat horizontal line. And an undefined slope, like what we had here, this is an undefined slope. That means that this table would give me a graph like this that has a completely vertical line. Next, let's talk about how you can use slope-intercept form to find your slope, find the intercept, and eventually graph. A linear equation written in this form is slope-intercept form, and you notice it's y equals mx plus b. Definitely, I'd be getting that in your notes. This is an incredibly important form that you have to know. The slope of the line is m. Whatever number you see in front of x, that's the slope. That tells me the rise-run ratio of the line. And the y-intercept is the b value. That tells me where the line crosses the y-axis. So whatever number this is, that's how many units up the y-axis my line will be meeting the y-axis at. A linear equation written in this form, where m is 0, would be reduced to y equals b, and it's called a constant function. Constant functions have a horizontal line, so it has 0 slope. Remember, 0 slope is that picture. It's a completely horizontal line. 0 slope. Let's quickly work a few of these. Identifying slope and y-intercept. The first one ought to be easy. Y equals 3x minus 4. Do you notice that this is in slope-intercept form? If it's in slope-intercept form, this is a piece of cake. The slope is 3 and the y-intercept's 4. That's it. You're done. You found out that the slope of this line has a ratio of 3 to 1, 3 up, rise 3, run 1. And the y-intercept would touch the y-axis at negative 4. This question, part B, this is like saying y would equal 0x plus 6.5. So you notice the slope is 0 and the y-intercept's at 6.5. That's what they're telling you here. C would be the one I'm most worried about. Let me get this writing out of here. I just wrote here. I wanted to give you a quick reminder that, warning, on a problem like this, first of all, what form is that? I hope you're sitting there listening and saying, wait a minute, that's standard form. Standard form doesn't tell you slope and it doesn't tell you the y-intercept. You have to rewrite this in slope-intercept form first. So look at what they do down here. They're going to isolate y, get y by itself. That's slope-intercept form. So we're adding 5x to each side. So you have negative 1y would equal 5x minus 2. They're dividing each side by negative 1, and dividing by the negative 1 will change the signs. There is an equation that is in that form. Okay, so can you see negative 5 is m. Negative 5 is the slope, and the y-intercept is a 2. So there's my slope and y-intercept. I would like you to quickly try on these three. Okay, I'm back. So for number 6, that should be an easy one. The slope is negative 6. The y-intercept's a 1. In question 7, really that should be an easy one too, because when you look at this, you got to think y equals 0x plus 8. The slope is 8, and I misspoke. The slope is 0, I meant to say. Slope 0, y-intercept 8. Now this one, you notice this is in standard form. Standard form doesn't tell me y-intercept and slope. I got to quickly solve for y. Take away x, divide everything by 4, separate fractions, negative 1x over 4 is negative quarter x, and 10 over 4 is 2.5. You see my slope is negative quarter, and my y-intercept is 2.5. Now that you know how to find slope and y-intercept, you should be able to graph easily without a calculator. So let's take this example. Graph 2x plus y equals 2. Identify the x-intercept. So first of all, that's not in slope-intercept form. We have to rewrite that. So they're going to quickly take away 2x from each side, and y would equal negative 2x plus 2. The y-intercept is 2. So this is what you do. You go to your graph paper and you go 1, 2 up, and you put a point. You see how the slope is negative 2? That means the rise over run should equal negative 2. So negative 2 is the same as negative 2 over 1. So from this point, go down 2 and write 1 and put another point. Go down 2 and write 1 and put another point, and there's the line. Can you see how the x-intercept in this problem is the point 1, 0, which is what they have here? Okay? So you should be able to graph slope-intercept form easy if you know the slope and y-intercept without even knowing a whole lot of math. Now, graphing from a verbal description. Let's talk about that next. This is just translating from function notation into slope and y-intercept. A linear function g models the relationship in which the dependent variable increases 3 units for every 1 unit the independent variable increases. So there we go with this vocabulary again. The dependent variable is y, the independent variable is x. So they're saying y goes up 3 for every 1 unit of x. So there's your slope. Let me write it up here. Your slope would be rise over run. The rise is the y's, that's 3, and the run is x, that's 1. The slope of this problem is 3 over 1. And then here's the next thing. Graph g when g of 0 equals 3. That means if you plug in 0 for x, you ought to get 3 for y. So let's graph this. 0, 3 is here. My slope is 3 over 1. Go up 1, 2, 3, and over 1. I guess I could go down 3 and left 1, and you see how I'm creating a line. Should be easy to graph from slope-intercept form. Okay? I'd like you to pause the video and try these real quick. For this first question, y equals 4x minus 4. Can you see how the slope is 4 and the y-intercept's negative 4? Okay, let's start here. The y-intercept's negative 4. So go to the y-axis, go down 4 and put a point. And then the slope is 4. That means go up 1, 2, 3, 4 and over 1. Put a point. Go up 4 and go over 1. Put another point. Go up 4 over 1. Put another point. Once you're done with that, take your ruler out, draw a line through it, and there's your line. Should be easy. Here's the next question. You notice this is in standard form. I can't have standard form. I need slope-intercept form. So take away 3x. That's slope-intercept form. My y-intercept's negative 3, which you can see I plotted here. And my slope is negative 3, which means I'll count with you. Ready? Go down 1, 2, 3, and over 1. Go down 1, 2, 3, over 1, and you can start plotting points, and there's your line. For this next one, again, standard form. I can't have standard form. I need slope-intercept form. Take away x. So I have 2y equals negative 1x plus the 6. Divide everything by 2. That's my slope-intercept form. Do you notice how my y-intercept's a 3, which is here, and my slope is negative 1/2. That means go down 1, right 2, down 1, right 2. Can you see a pattern of down 1, right 2? And there's your line. And for this last question, they said that the linear function h models a relationship in which the dependent variable decreases 2 units for every 5 units the independent variable increases. Now dependent is y is the rise, so the rise is negative 2, decreases 2, and the run, x, is 5. There's the slope of this problem. And graph h when h of 0 equals 4. That means if you plug in 0 for x, y is a 4. Okay, I got to graph this. Y-intercept's 4, slope negative 2/5. So here's my y-intercept of 4, and here's my slope of negative 2/5. Can you see? Go down 2 and over 1, 2, 3, 4, 5, and then down 2, 1, 2, 3, 4, 5, and down 2, 1, 2, 3, 4, 5. There's my line. They wanted me to label the y-intercept. There it is, 0, 4. And here's my x-intercept. It's 10, 0. And finally, the last question, or the last part, solving a real-life problem with slope-intercept form. Most real-life problems, slope is interpreted as a rate like miles per hour, dollars per hour, or people per year. So when you see this question, a submersible, like a little personal submarine, that is exploring the ocean floor begins to ascend to the surface. The elevation in feet of the submersible is modeled by this function, where t is the time in minutes. There's my independent variable. That's my x's, since the submersible began to ascend. Graph the function and identify its domain and range. Well, you can see the slope is 650 and the y-intercept is negative 13,000. Now, these real-life problems I would let you use a calculator on. Real-life problems, I do allow calculators. Okay? So you can see they had to make a big scale here. They got to get all the way down to 13,000. So 0, negative 13,000 would be a point. And then they decided to use intercepts. If you plug in 0 for t, y, or in this case, h of t is negative 13,000. But if you plug in 0 for the y value and you quickly solve this, which we'll do real quick, just so you can see how they're getting this ordered there. If I add 13,000 to each side, and then I divide by 650 on each side, I find out that t would be 20. Okay? So if I plug in 0 for h of t, t is 20. That's where they're getting the point 20, 0. Now you notice they're only plotting in this quadrant because the time has to be positive, x is positive amounts, and we're underwater. The water has to be negative amounts. Let's identify the domain. values of time go from 0 to 20. That's why the domain for time is 0 to 20. Now look at the elevation below the water. The lowest we are is here at negative 13,000, and the highest is, well, when you're at sea level 0. That's why the range is from negative 13,000 for H up to 0. The slope, interpret the slope. What's the 650 mean? That means we are increasing 650 feet per minute. That's what 650 represents, 650 feet per minute. So when they say interpret the slope is 650 feet per minute. And what are the intercepts? Well, this means that the person is back at sea level on top of the water after 20 minutes. 20 minutes, 0 feet. And at 0 minutes, they are 13,000 feet below sea level. I'm going to stop the video there. If we have questions, make sure you ask in class.